Hi everyone, welcome to Civil Engineering Tutorials. In this video, I will show you how to make BBS of RCC Lintel beam. Means bar bending schedule of RCC Lintel beam. I will show you in this video. So if you are new to my channel, then click the subscribe button and the bell icon to stay updated with all new videos. Also, don't forget to follow me on Facebook, Instagram and Twitter to get all kinds of updates. So let's get started. So here you can see this is the lintel, or you can say lintel beam also. So first the definition. A bar bending schedule or BBS is a document showing the list of structural members, bar mark, type of reinforcement, size of rebar, number of rebar for each members, cutting length, total length, shape and location, spacing, position of all reinforcement in the working drawing. It ensures that reinforcement cutting, bending and placement are carried out in the most efficient manner on site. It also guides against the excessive waste of reinforcement by minimizing the number of useless offcuts. Technically, bar bending schedule BBS is a document that provides detailed information about the reinforcement steel bars required for a specific structural element such as lintel beam. It includes the total length of main bars, the number and length of stirrups, and the weight of steel required. Creating a BBS helps ensure accurate and efficient reinforcement placement during construction. So, what is importance? The importance of BBS is that it helps in improving quality control at the site. It reduces construction costs and time, reduce reinforcement wastage in cutting, helps in stock management at the site, and provides a check on theft. So, hope you understand the definition and importance of BBS. So first, calculate the length of main steel bars. We'll calculate the length of main steel bars. So, how to calculate the length of main steel bar? This is the steel bar. Here you can see. This is the steel bar lintel. Okay, this is the lintel. So, length of main steel bar is calculated by subtracting the clear cover on both sides from the length of the lintel, multiplying this length by the number of bars to get the length of main steel bar. So, I'll show you. This is the definition of how to calculate length of main steel bar. I'll show you step by step. So, first, length of lintel 3000 mm or 3 meter. This is the lintel, length of lintel or lintel beam, whatever you can say. I have taken 3 meter. Clear cover for each side 25 mm. So, here clear cover you can see. Now, center distance between stirrups 150 millimeter. So, this is the lintel, 3 meter lintel beam. Okay, this is steel, and these are stirrups. Okay, and clear cover here, both side, this side and this side, 25 mm clear cover. So, center distance between stirrups 150 millimeter. Here you can see 150 mm center distance. Diameter of bar 12 mm. Here, this is you can see here. Diameter, I have 4 numbers of bars. Diameter of bars 12 mm. So, this is the section I have taken here, lintel beam, and if I see from this side, I can see section on x-axis like this. Okay, like this I can see the section. So 4 bars I can see, and diameter of bars 12 millimeter dia. Here you can see this side 2 and this side 2, 12 mm dia, and stirrup dia 8 mm dia, center to center distance 150 mm. Diameter of bar 12 mm, 4 dia, this side 2 dia 12 mm and this side 2 dia, and stirrup 8 mm dia. Hope you are clear. And spacing means center to center distance 150 mm. Number of bars 4 numbers. I have already said 4 numbers of bars. Now length of main steel bar, its formula is length of one bar into number of bars. So length of main steel bars formula, length of one bar into number of bars. So first I have to calculate length of one bar. Length of one bar is length of lintel minus clear cover for both sides. So length of lintel. So length of one bar, length of lintel 3 meter minus clear cover 25 for both sides, 2 into 25. So this is 25. So for both sides 2 into 25, 2950 millimeter, that is 2.95 meter. So length of one bar is 2.95 meter. So this is 3 meter minus both side clear cover we have deducted. Now we got length of one bar 2.95 meter. Now length of main steel bar we have to calculate. Length of main steel bar is length of one bar into number of bars. So length of one bar we have calculated 2.95 meter into number of bars 4. So 2.95 meter into 4. Length of main steel bar we got 11.8 meter. This is length of main steel bars, 11.8 meter. Okay. So we got length of main steel bar, that is 11.8 meter. Next, we have to calculate weight of steel for main bars. So diameter of bar 12 mm. Here you can see 12 mm, 4 numbers of bars, 12 mm, this side 2, this side 2. Length 11.8 meter. We have calculated length of main steel bars 11.8 meter. We have calculated. Weight of steel for 12 mm dia bar is weight of steel. Its formula is D square into L divided by 162. D is 12 mm dia, diameter of bar 12 mm. L we have calculated 11.8. So put the formula, put the values 12 square, D square, 12 square into 11.8 length divided by 162. We are getting 10.5 kg. Weight of steel for 12 mm bar 10.5 kg. We got 10.5 kg weight of steel for 12 mm bar. Now weight of steel for 12 mm bar 10.5 kg we got. Now next, number of stirrups. We have to calculate number of stirrups here. Length of lintel 3 meter or 3000 millimeter. You can see here. Center to center distance between stirrups 150 mm. Spacing 150 mm. Number of stirrup formula length of lintel divided by center to center spacing or center to center distance between stirrup plus 1. So number of stirrups, length of lintel 3000 mm divided by center to center distance 150 mm. Here you can see 150 mm center to center distance plus 1. We are getting 21 numbers. Number of stirrups we are getting 21 numbers. So number of stirrups we have calculated 21 numbers. Next, total length of stirrups we have to calculate. So total length of stirrups, I have created this drawing for better clarity. Cutting length of stirrups first you have to calculate. So its formula is 2 into A plus 2 into B plus hook minus bend. Now what is A and what is B? This is A. Okay. So this is B. What is A? A means this length, this width minus this both side clear cover and minus half of this stirrup dia. Half of this stirrup dia both side. Total depth minus both side clear cover minus half of stirrup dia. That is A. Both sides are same. So that is also B. So A is inner depth distance and B is inner width distance. This is depth. So inner depth distance means this length minus both side clear cover minus half of stirrup. Means we have to go middle of stirrup. We have to go till middle of stirrup. Here to here this distance and here to this side also, here to here this distance B. Depth and width both are same. This is 150 into 150 by 150. So A is equal to beam depth. Beam depth is 150 mm. This is beam depth minus clear cover on both sides. This side clear cover and this side clear cover. Both side clear cover. Minus half of bar dia. Means stirrup dia. This half of this stirrup dia into 2. 2 for both sides. Half of bar dia, half of stirrup bar dia into 2. This side also. So we have multiplied with 2. So beam depth minus clear cover on both sides minus half of stirrup dia into 2. This is A. B also same. Beam width. This side also 150. Both side 150 minus clear cover on both side 25 minus half of bar dia into 2. So beam depth 150 mm. Clear cover for each side 25 mm. Here and here this side both side 25. This is 150 mm. This side also 150 mm. Clear cover for each side 25 mm. Diameter of stirrup 8 mm. This diameter means diameter of this stirrup. This stirrup diameter 8 mm. Here you can see in this 8 mm dia, center 150 mm. Sorry, 150 mm center distance. Diameter of stirrup 8 mm. Now hook 10D. D is diameter of stirrup. 2 hooks. Okay. Hook is 10D. Usually it's second 10D. We take 10D. So 2 hooks here. 2 hooks. This side and this side 2 hooks. So for 2 hooks, hook formula 10D. Okay. We have 2 hooks. So 2 into 10D to get hook. D is diameter of stirrup. Diameter of stirrup 8 mm. Okay. So bend. 5 bends. So we have 5 bends. 1, 2, 3. Here 2 bends. Total 5 bends. Here 1, 2, 3 and here 2 bends. Total 5 bends. So from these 5 bends, 3 bends are 90 degrees. So for 90 degree we will take 2D. This and this. These 3 bends are 2D because 90 degree and 2 bends 135 degrees. Here these 2 bends are 135 degrees. So for 135 degree we will take 3D. For 135 degree we have to take 3D and for 90 degree we have to take 2D. So 3 bends are 90 degrees. So for that 3 bends we have to take 2D and for 2 bends that is 135 degree. For these 2 bends we have to take 3D. Hope you understand. So total 5 bends, 3 bends 90 degree 2D, 2 bends 135 degree 3D. Now A, beam depth minus clear cover on both sides minus half of bar dia into 2. This is this distance A, total minus clear cover both sides and half of stirrup dia. This to this, middle of stirrup dia. So A is equal to 150. This is 150 minus 2 into 25. Clear cover on both sides. This side and this side clear cover minus clear cover 25 mm, so 2 into 25 mm minus half of bar dia. Bar dia means stirrup dia. Don't get confused. This is stirrup dia. Half of bar dia, diameter of stirrup. 8 by 2. Half means half of bar dia means 8 by 2 into 2. Both sides for into 2 is equal to 92 millimeter. This is A. So B also same because B and width both are same 150 150. So B also same 92. Okay. Same formula for B. 8 by 2 into 2 92 mm, and B also same, this side 150, this side 150 minus 2 into clear cover, this side and this side clear cover minus 2 minus 8, this side half, so 8 by 2, this side 8 by 2 into 2 means 4 by 2 is equal to 92 millimeter. Okay. So A and B we got 92 millimeter. Now cutting length of stirrup we will calculate. 2 into A plus 2 into B plus hook minus bend. This formula. Now we have to calculate bend also. So 3 bends 90 degree is equal to 2D. For 90 degree we will take 2D. So for 3D, 3 bends. So 2D means 2 into 8. For 3 bends into 3. 2 bends 135 3D. 3D means 3 into 8 for 2 bends into 2. So for 3 bends 3 into, for 2D 2 into D diameter 8. 3 into 2 into 8. 2 bends. So 2 into 135 3D. So for 3D 3 into dia 8. Now cutting length of stirrups we will calculate. 2 into A. 2 into 92 plus 2 into B. Here 2 into A, 2 into 92 plus 2 into B. 92 we have calculated plus 2 into B. 2 into B. 2 into 92. Here 92 plus hook. Hook we have calculated 10D. So 2 numbers of hook. So 2 into 10 into D. Okay. 2 into 10D, hook is 10D, so 2 numbers of hooks, 2 into 10D, 10 into D is 8, stirrup dia 8, 2 into 10 into D, 2 numbers of hook, 2 into 10D, 10 into D is 8, 2 into 10 into 8 minus bend. So we have 5 numbers of bend, so from 5, first 3 bends 90 degree, for 90 degree 2D, for 135 degree 3D. I have already said these 3 bends 2D 90 degree. So 3 numbers of bend into 2D. 2 into, for 2D 2 into 8. 8 is dia. 8 is dia minus, for 135 degree we will take 3D. 2 numbers of bend, so 2 numbers of bend means 2 into 3D, 3 into dia is 8. So we are getting 432 mm or 0.43 meter. I hope you understand. Cutting length of stirrups we have calculated 0.43 meter. Now total length of stirrups for 21 numbers. Sorry. Cutting length of stirrups into number of stirrups. So cutting length of stirrups for 21 numbers means total length of stirrups. Cutting length of stirrup into number of stirrup. So cutting length of stirrup we have calculated 0.43 meter. And number of stirrup 21 numbers we have calculated. So 0.43 meter into 21 numbers. We are getting 9 meter. Total length of stirrup for 21 numbers we are getting 9 meter. Next, steel for stirrups. We have to calculate steel for stirrup. The weight of steel for stirrups, its formula is D square into L by 162. D is diameter of stirrup, 8 mm. L is length of stirrup 9 meter. We have calculated this. Length of stirrup L. Weight of steel for stirrup D square L 8 square into L 9 divided by 162, 3.5 kg. So this is weight of steel. We have calculated. So weight of steel we have calculated 3.5. Now length of main steel bar 11.8 meter. Length of one steel bar main steel bar 11.8. Now weight of steel for 12 mm bar 10.5 kg. This is now number of stirrups. Number of stirrups 21 numbers. 21 numbers of stirrups we have calculated. Number of stirrups. Now here total length of stirrups 9 meter. Number of stirrups 21 numbers. Total length of stirrup 9 meter. Now weight of steel for stirrup 3.5 kg. We have calculated. So this is the BBS of lintel beam. I hope you like this video, and if you find this video helpful, don't forget to like, share and comment.